Dear students, today we are going to discuss a bit difficult topic where we shall be seeing that what is the motion of a charged particle which is placed in uniform magnetic field. Here we assume that a charge Q is moving with a velocity v in a magnetic field B such that the velocity of the particle is making theta angle with the magnetic field, direction of magnetic field. Here we take magnetic field in along positive y direction and we take the velocity of the charged particle at theta degree with the magnetic field. Here we can have the two components of the velocity, one along a direction which is perpendicular to the magnetic field, we call it perpendicular component of the velocity, and one along the magnetic field, direction of magnetic field, we call it parallel component of the velocity. So we can even write it like v parallel and we can write it like v perpendicular. Now here you see for the component v sin theta which is perpendicular to the magnetic field, some Lorentz force will act on the particle. This Lorentz force will be given by the general relation qv sin theta vb, and when you expand v cross b you get vb sin theta. So here we can think that a perpendicular component will interact with the magnetic field and the force acting on the particle will provide the necessary centripetal force to keep the particle moving on a circular path. Since this force is perpendicular to the component of the velocity, perpendicular to the magnetic field of the velocity, so this force will not change the magnitude of the velocity because it is perpendicularly acting always perpendicular to the component of the velocity. So that means magnitude of velocity will not change. Now what will happen then? Since this force is along a direction perpendicular to the velocity, therefore only the direction of velocity will change, and as a result the particle will be forced to move on a circular path, and that circular path will have a radius given by the relation mv square by r, that is the expression for centripetal force which is provided by this Lorentz force qv sin theta into b. This is the Lorentz force which provides the necessary centripetal force, and therefore on solving this we get the radius of the circular path will be mv sin theta by qb. Also the time period of the particle on rotating in the circular path will be given by, time period is what? You know, total distance. Time period means you travel total distance, and that divided by speed will give you time, because you use the relation s is equal to ut, very common. For the speed we have been using it, so therefore you can see s is equal to ut, therefore t is equal to s upon u. What is s? It is distance. So distance is total distance covered on a circular path is 2 pi r, and the speed is v sin theta. So total distance 2 pi r divided by the speed v sin theta, you get the time period of rotation, means time required to complete one circular path. Therefore time period is now known to us, radius of the circular path is now known to us. So using the relation omega, angular velocity is equal to 2 pi by t, and so we can write for 2 pi by t you can write, you see, t is equal to 2 pi r by v sin theta. So for t you can write this value 2 pi r by v sin theta in the denominator, and in the numerator you already have 2 pi. So 2 pi and 2 pi, these two cancel each other. You do this exercise yourself. I am just putting the value of t time period, and on solving we get v sin theta by r. So that means once we got this relation, angular velocity is equal to v sin theta by r, we can feed the value of r, which is mv sin theta by qb, and therefore when you put the value of r, which is r is mv sin theta by qb, and you solve v sin theta in the numerator and that in the denominator cancel each other, so only we are left with m upon qb. When we reciprocate it, it becomes qb by m. So that is the angular velocity of the particle which is moving on the circular path when it is moving with a velocity v at angle theta with the direction of magnetic field. Then this will be the time angular velocity of the particle. Time period of the particle will be given by this expression, and the radius of the circular path will be given by this relation. So these are very important because we used to apply it for solving numericals, and we have other applications as well. So now apart from this perpendicular component, we have v cos theta. Now since v cos theta is along the direction of magnetic field, so you know the relation Lorentz force is charge into v cross b, and if there is a zero angle between this velocity component and the magnetic field, so no Lorentz force will be acting along the Lorentz force will be acting due to this component v cos theta. But v cos theta is existing, means some component of the velocity exists along the direction of y. So while the particle is moving clockwise, when seen from the top, while the particle is moving in clockwise direction, there is a motion of the particle also in vertically upward direction. So what happens if there were no vertical motion of the particle? It would have continued to move in some circular path. But since it is having some component in the vertical direction, so the particle is moving in the circular path, but each time it is advancing along the positive y direction. So that means the particle will have a spiral-like path. So this is very important to understand that. I repeat the whole thing. When a particle is moving with a velocity v at theta degree with the magnetic field, then due to the perpendicular component of the particle's velocity, Lorentz force acts on the body, which is providing the necessary centripetal force mv square by r to keep the particle moving on a circular path. Now apart from this, due to parallel component of the velocity which is along the magnetic field, there is no Lorentz force acting due to this component, but the component of the velocity is responsible for keeping the body moving in along y direction. So that means while one Lorentz force is keeping the body to move on a circular path, the parallel component of the velocity of the charged particle keeps the particle moving in upward direction. So that when we combine these two, the motion of the particle becomes a spiral-like, means had there been no vertical motion, it would have remained moving in a circular path. But since there is also a component of velocity along vertical direction, so the particle starts moving in circular path, but it keeps advancing up and up. So that means it follows a spiral-like path as shown in the figure. That's all for today. Thank you and have a nice day.